Hey folks, let's learn about the pod memory hog fault. Pod memory hog is a Kubernetes chaos fault which injects heavy memory usage inside a Kubernetes pod. So it can be used for various types of failure testing, such as testing application resilience under high memory stress, then validating the pod auto scaling for memory stress. It can also be used for performance optimization under heavy memory usage for the applications. Then it can be used for planning the capacity of resources that are required to execute a certain application. So, yeah, those are some of the use cases of the pod memory hog fault. Now, let's take a look at the different tunables of this fault. If we go inside this fault, we can see that we have defined our app namespace under the target application tab. That is the application that we want to target. So we have the namespace, that is where your application lies. Then the resource of the application, which happens to be deployment, as well as the labels of that pod. So both the deployment and the pod have the same label. Moving forward, we have the fault tunables. So the first tunable that we have is the total chaos duration, that is the duration through which the chaos should be injected. Then we have the memory consumption, that is how much memory should be consumed. So this is in bytes. So 1024 bytes have been provided. Then the number of workers, that is how many number of worker processes should be started, which will be consuming the above mentioned amount of memory. Moving on, we have the pods affected percentage, that is how much, what percentage of pods should be affected as part of the fault. So we can see that no value has been provided, so it will by default take one, that is only one pod will be affected as part of this fault. Then we have some other details such as the lib image, that is what image should be used for executing the fault, and the stress image, that is from where the stress ng utility should be used, from which image it should be used. Then your Kubernetes container runtime, as well as your container runtime socket path in each node, and so on. So yeah, with these details, we also have a probe defined. This probe is nothing but a HTTP probe, which helps in monitoring the target application. It just pings the target application and continuously and checks that whether it is healthy or not throughout the chaos duration. So yeah, with that, let us try to execute this fault. So right now we have executed our fault, and if we go to our terminal, we can see that currently the memory consumption is pretty low. It's only 51 megabytes. So we are using the kubectl top pod command in order to observe the resource consumption of the target pod. If we go back to our console, we can see that the fault is yet to start. So let us wait for the fault to start. So now we can see that the fault is in running state. The helper pod is running right now. So now we can see that as a result of this execution of this fault, the memory has steeply increased to 286 megabytes. And we can see that the fault execution is still underway. So let us wait for the fault to complete. So now we can see that the fault is almost complete. The chaos injection is over and we are just updating the chaos result. Meanwhile, let us wait for the chaos river to take place and the memory to slowly return back to its original resource value. And we can see that it's already listening. We are right now back to 50 megabytes. So yeah, with that, our fault execution is over. We can see that the memory consumption has returned back to 50 megabytes. And we can also see that the fault execution is complete and we have received a 100% resilience score. So that is because we have only one probe here and that has passed. So if we expand the probe, we can see that it is an HTTP probe which was calling to this URL, and we were able to actually get the URL, and the response code that we received from that URL is 200, which determines that the card service endpoint was available throughout the chaos duration. So yeah, with that, we have learned about the pod memory hog fault. Thank you.